Hi friends, in this session we will try to discuss regarding electric flux. So this topic we will discuss. So in the last session we have discussed regarding magnetic flux and we have understood in detail like how the formula is derived and what is the SI unit and all. So similarly we will discuss in this session regarding electric flux. So as I already told you what is this flux? So flux is nothing but to flow or the number of field lines passing through the imaginary field lines passing through the surface area. So this is the meaning of flux. Now electric flux we are trying to understand. So what is this electric flux? Okay, so it is a definitely a type of flux. Okay, so then the number of electric field lines, as I told you in the magnetic flux, we will try to cover the number, try to understand like how many magnetic field lines are passing through the surface area. Whereas in case of electric flux, the number of electric field lines passing through a closed area, we will try to understand. Okay. So here we will count the number of electric field lines. Since this is electric flux, definitely electric field. See, magnetic flux means magnetic field lines we will calculate. Electric flux in the similar way, we will try to calculate the number of electric field lines which are passing through a closed surface. So because of this, we will try to understand with the help of this particular diagram. So flux phi is equal to EA cos theta. So this is the definition. So how it is derived, we will try to understand later. But now for time being, so this is the surface area, whichever is I'm pointing out now. This is the surface area. And this is the imaginary lines or electric field lines, I can say. Okay. So because it is electric flux, these are electric field lines. Okay. So now we want to calculate, our main goal is to calculate the number of electric field lines passing through this surface area. So this is nothing but the electric flux. This is the meaning of electric flux. So now we will split this particular component into two components, that is A and E. Okay, so A and E. You can give any name, but for understanding, better understanding, it is given as E. So we will decompose this particular component into two, that is A and E. Okay, so an angle is made between them, which is theta. So with respect to this, we will try to understand how the formula can be derived. Okay, so this is perpendicular to the area of this one. So this is perpendicular to the surface area, correct? So this is surface area, it is perpendicular. So in that way, so what is this electric flux through a plane area? It is defined as electric field line times the component of the area perpendicular to the field. As I already told you, this is the area which is perpendicular to the field. Okay, so electric flux, now we are in a position to understand what is this electric flux and how it can be calculated. So electric flux is equal to electric field. This is electric field, this is area, this is area. Okay, so this is area which is perpendicular to the electric field. Okay, and multiplied by angle between planar area and the electric flux. So this is nothing but the theta, which is the angle between A and E, which is theta. So then definitely we will try to derive the formula in this way, which is, I will repeat once again. So electric flux is equals to, which is again a phi. Okay, this is also electric flux is represented by phi. So electric flux is equals to electric field. Okay, how much electric field is there? That magnitude multiplied by area. So how much area is there? So this is area which is perpendicular to the this field. Okay, so and angle between A and E. So this is, hence we can easily, with respect to this line, we will try to understand the equation as phi is equals to E means electric field, A means area, and this is cosine of the angle between planar area and the electric flux. So hence phi is equals to EA cos theta. So usually representation of flux is phi. So if we want to, for convenience, as there are two types of fluxes, that is electric flux and magnetic flux. So electric flux is represented by phi E, which I'm trying to show it you here. See, it is represented by phi E, and magnetic flux is also phi m, we can say. Okay, as per these are the standard, actually phi is standard. So electric flux has the SI unit. Now we will, now with this we measured what is the magnitude of flux which is going to be there. Okay, so now with what unit we have to measure this particular flux, electric flux. So electric flux has the unit of voltmeter. So this is the unit of voltmeter, or equivalently, as we know in physics we have some equivalent units also. Okay, so meter, centimeter, like that. But both are used to measure, but SI unit is meters. So in this way, so voltmeter is also unit of electric flux, or equivalently Newton meter square per coulomb. Newton, this is N means Newton, M meter square per coulomb is the unit of this electric flux. So your SI unit is voltmeter. So these are additional units which I already told you, which is in different systems, SI unit systems, CGS. So all are there. So with respect to SI is the standard this unit. So voltmeter is the unit for the electric flux. So and as I already told, it is represented by phi E. Okay. So this is all about electric flux. So if you have any doubt, please do write a comment in the YouTube comments section. And if you want to know, apart from this, if you want to know any of the topic from physics or electronics in particular, so please comment in the YouTube comment section, and I will try to cover it in a subsequent classes. Okay, so please do subscribe to my YouTube channel and press the bell icon to get the latest updates. So till then, thank you.